our mini series on the circle. And if you remember last time, we finished with x squared plus y squared is equal to r squared. And then we generalized this to say that this could be ax squared plus ay squared is equal to r squared, where we're allowing a to be any positive real value. In this case, it's 1, 1 and 1. The only real condition there that I have is it has to be the same, because if it's not the same, and then it turns out that I have an ellipse. And we'll look at the ellipse a little bit later in the series. So I just have my a have to be the same. Now, just to get a quick picture here, what we did is we said, well, this is my center, this is my hk, or in this case, it's going to be 0, 0. And we said, well, I'm going to go some distance out. This is r. So around this circle, these are all the sets, all the pointed sets that are r distance away from the center. If I take any point here, x, y, I can say, well, the distance from here to there is going to be using the distance formula or Pythagorean theorem. If that's x, y, then this is x and this is y, and I get over here r squared is equal to x squared plus y squared. I can get that directly using the Pythagorean theorem. So r squared is equal to x squared plus y squared. Or if I can plug it into the distance formula, and I would get the square root of x minus 0 squared plus y minus 0 squared is equal to r. To get rid of the square root, I square both sides because r is that distance, so I square both sides. This is just x squared, that's just y squared, so I end up with x squared plus y squared is equal to r squared. Today, though, we're going to look at what happens if it's not the center. And notice that it was, we said in general that it's going to be x minus h, or that center value. And in this case, this is if my center value is 0, because this right here is actually my h value. That right there is my k value. So if I look at my circle, and I let my circle be somewhere out here, where my center is hk, and I go out some r, this is going to be r, and I've got some value here. This spot is going to be a spot on the circle. Now, the fact that I'm in quadrant 2 doesn't matter. I just picked an arbitrary point. So I have some hk. This is going to work from anywhere on the plane. I've got some hk and some r, but let's call this point xy because this point satisfies the condition of being r distance away from the center. And we can say, well, every point on here is going to have to be r distance away from the center. So to satisfy the equation, what we would have is the square root of x minus h quantity squared plus y minus k quantity squared is equal to r squared, or my r, that's my distance. And to get rid of the square root, I'm going to square both sides. So that's going to give me x minus h squared plus y minus k squared is equal to r squared. And this is the general form of a circle. Now I can also expand this by saying, well, if I wanted this to be a x minus h squared plus a y minus k squared, I can do that. The only condition again is this a has to be the same value as that a. We'll show what that does here in a little bit, but I have to have that same value. In general, though, we can just let that be 1 because I can actually take it to be part of the radius if it's not 1 pretty easily. So my standard there is going to be x minus h quantity squared plus y minus k quantity squared. And I'll show you how we can do this here in practice. So if I were to ask you to graph the equation of x minus 3 squared plus y plus 2 squared is equal to 16. Well, I would look here and say, well, what's my center? Now, this is going to be, my h there is going to be 3, because this is x minus 3 squared. So h is equal to 3. Now, the way I actually like to think about it is what's going to make that 0. So what's going to make that 0 is going to be 3. Now, over here, my k you're going to have y. The k is actually minus 2 because it's what makes this part 0. Well, the thing that's going to make that part 0 is if y was negative 2. So in this case, k is negative 2. And if you wanted, I could write it as minus 2 squared. And there I get the y minus k, where k is negative 2. You can do that as well. I tend to just think of it as what's going to make it 0. So, and I can write this as 4 squared. So my center is going to be 3, negative 2. So 1, 2, 3, negative 2 right there. And I'm going to be going 4 in each direction. So I go 4 in this direction, I'm going to be here, 4 in this direction, 4 in this direction, 4 in this direction. And there's my circle. And that's not perfect. It should be a circle that looks more elliptical, which we'll talk about here in a little bit. But the key thing is my distance here is the same as my distance here. And in fact, it's the same as my distance here, it's the same as my distance here. So everywhere I've got the same distance or the same r, which in this case is 4. And I'll show you another way of how this works. If I were to go to my standard, so let's just say x minus 3 squared plus y minus 5 squared is equal to 4. In this case, my center is going to be 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5 right there. And then 2 in every direction. So 2, 2, 2, 2. There's my circle. And you can notice that if this is the point 3, 5, then this is going to be the point I'm adding to the x. So this is going to be point 5, 5. This is going to be point 3, 7 because I'm adding to the y. This is going to be the point 1, 5. And this is going to be the point, I'm moving the y, so it's going to be 3, 3. Now, let's suppose I want to zero out one of these terms. Well, if I put in 3 for the x, notice that's going to zero out one of my terms. So it's going to zero out this term right here. So if I were to put in my 3, right here, what you'd get is 3 minus 3 quantity squared, and I'm going to try and figure out what my y is. So that's going to be y minus 5 squared is equal to 4. Well, that's just 0. 3 minus 3 is 0, 0 squared is 0. So take a square root on both sides. Now notice that when you take a square root, it's very important that I'm going to get plus or minus the square root of 4. This plus or minus is key. So what you actually end up getting is y is equal to 5 plus or minus 2. Now this is two values here, one of which is y is equal to 5 plus 2. The other is going to be y is equal to 5 minus 2. So this is going to be y is equal to 7. This is going to be y is equal to 3. And you notice that I put in 3 for the x. So I should get the point 3, 7 from this guy. So I'm going to have the point 3, 7. I'm going to have the point 3, 3. Well, look at that. When x is 3, I get 2 points. I get 3 and I get 7. And a very similar thing happens when I put in 5 for the y to zero out the y term. So if I put in 5 for the y, well, you're going to have x minus 3 quantity squared plus 5 minus 5 squared is equal to 4. Well, this is going to be 0. If I take a square root, you're going to have x minus 3 is equal to plus or minus the square root of 4. So you're going to have x is equal to 3 plus or minus 2. That means that x is equal to 3 plus 2, and x is equal to 3 minus 2. This is x is equal to 5, and x is equal to 1. So I'm going to expect, and that's the point when I put in 5 for the y. So I'm going to expect the point 1, 5, and I'm going to expect the point 5, 5. Well, there they are. So all of these points here on this equation work. And in fact, any point there is going to work. If I take this point, that point there is going to work as well. I would just have to figure out what those points are. But I can see the vertices. So by getting the center, those move it to that center, and it's what's gonna zero out each term. Just like if I had the 0, it told me how much I was moving. So it tells me where am I moving on the x compared to where am I moving on the y. All right, so that covers the circle. I will see you next time when we continue with the ellipse.